how many processors can go on a bus. And I should say also that since processors have gotten much faster over the decades, that we've had to work very hard even to keep up with a small number of processors through this bus. Intel, for example, has supported on a front side bus a maximum of 4 processors, and they did that for, I guess, close to 20 years. And we finally realized that it's just not feasible that the bus isn't fast enough to support 4 processors. So they need to go beyond that. Now, there's a second approach that's been around even longer than this scheme, I should say, which is referred to as a directory-based scheme. The idea there is that it's a point-to-point interconnect, but memory has, in addition to the data, it also has something called a directory off to the side here. And the directory is responsible for keeping track of who's got this cache and what state it is in. And so all memory requests now involve first asking the directory decides what to do, and then as appropriate sends a request to memory, and memory then sends the data to the CPU, or it sends a request to this cache, says you've got the only valid copy, memory doesn't have a valid copy, so you send it across. So the effect is a 3-legged action like this, where the directory sends a request to this node, and this node sends the data across. So the advantage of this scheme is that unlike a bus, it can scale to very large numbers. The disadvantage is that it takes 3 legs, because you have to look it up in the memory before you even know whether the data is in main memory. If it's someplace else, you have to have 3 legs here. So the good news is it scales to very large numbers. The bad news is it's slow for big systems, but that's okay. But it's also slow for very small systems, which is not so good. So that scheme has never really caught on, but it's always sort of been in the background. So now, having said that, let me say a little bit about where we were when I started this work in 2001 and how these 2 schemes that I just described fit into it. So in 2001, we were being told by the technology groups at Intel that point networks are going to be far superior to buses, and you really want to build systems on that. So you want to develop a networking protocol that works on point-to-point networks and is efficient for a small number of nodes, which eliminates directories, as I described them, has benefits of a bus protocol. Basically, we want to be able to go out and back a single pair of transactions to get data in most cases, like we do with the bus. We didn't want a protocol that requires you to try and maybe get an answer that says, try again, that didn't work, or we can't handle email or something. So we wanted it to handle requests immediately and queue them rather than forcing retry. We wanted to be able to handle large numbers of concurrent requests because we recognize that multiprocessors are going to push the bandwidth limitations of the interconnection network, whatever that is. We wanted something that didn't make heavy demands on the interconnection network, but rather would simply assume that the system underneath reliably delivered packets. So we didn't want any ordering constraints. In fact, we said if node A is sending 2 messages to node B, they may arrive in the reverse order than they're sent in. That's okay. That actually turns out to be a fairly significant problem, because you would like to be able to know that when a message arrives, that other messages that were sent earlier have already arrived. So that actually turned out to be one of the more difficult aspects to deal with. And finally, we wanted this to scale to a large number of processors. Intel then and now saw their sweet spot as a small number of chips. That's grown a bit because a chip now has multiple processors on it, but they still are interested in relatively small numbers for much of their marketplace, the dominant part of their marketplace, although they and everybody else increasingly are worried about very large systems that can scale to hundreds or thousands or tens of thousands of processors.